All right. So we just showed you global policy portability, and we showed you intra-region. We showed you policy portability. Now we're going to start doing the fun stuff because resiliency is one of those things that's absolutely required. Okay. And when we think about resiliency, the policy compute engine, we think about it intra-region, and then we also think about it in terms of like catastrophic regional failure, okay? And those are sort of the two separate demonstrations that I'm gonna do for you, okay? Now, one of the things that we learned earlier on, and this happened years ago, is we called it the eggs in one basket problem, okay? So one of the great things about having a pure software-based solution is by decoupling from any form of infrastructure, it effectively allowed us to really create the ability to have different types of HA architectures and not have to dictate how customers were going to deploy and get their resiliency out of it, okay? In fact, one of the demos that we were thinking about doing today is just bringing up an entire new supercluster for DR, but that's not even realistic, so we thought we'd actually have a warm standby sitting there, which we'll get to in a moment, okay? Now, and by not being coupled to hardware, it's allowed us to separate out the nodes of the cluster across like an availability zone without any infrastructure requirements, because remember, it's just an RPM install. You have a question?
Yep. What happens if all PCs goes down?
Good question. If all the PCs go down in all the regions,
yes,
the vends fail freeze. So they'll maintain their last known good policy state. Okay?
I wanted to hear that.
Okay. All right. So that's what we're going to show you. And one of the things we're going to do here is once we start having a intra-region set of failures, that shouldn't mean your business stops, okay? So once we start failing things, we're going to start scaling stuff up inside that region, okay? Which I think is a very important point. So here we, what happened? Can we go back to my PowerPoint, please?
Yep.
So here's what we're going to do. So we're running six node clusters in each region. And so we're not going to fail one node. We're not going to fail two nodes. We're going to fail three of the nodes in this cluster. And when we fail those nodes in this cluster, that is the point we will begin scaling stuff up. Okay, so we're going to make it a little bit painful. And this sort of shows that you have a lot of flexibility over how you deploy the PCE. And by only making it a software-based install, there's a lot of flexibility you can do, which we'll get into in the next demo. It's really cool stuff. Question?
What's the difference between core node and the data node?
The question, let me repeat your question. What's the difference between a core node and a data node? A core node are the hosts or the nodes that serve up policy to the VEN. And also, it's where the UI is served up from, okay? The database nodes is a persistence tier. That's where the data is actually stored, okay? Now, this is earlier PJ talked about policy breadth. The wider you go with your core nodes, the faster your policies can be taken in by the VENs, right? I can tell you that we do massive policy computation and distribution, and the width of the PCE nodes allows us to do massive policy distribution and huge convergence in very short periods of time, okay? And so the balance that we think about when we talk to customers about their deployment is, what is your policy convergence times that you're looking for, and what type of failover you're looking for, right? Because that's how we'll design our superclusters. And because these are actually stateless, there are actually not a lot of information going on there. Maybe another networking field day we can do the deep dive into how the PCE is architected, but that's effectively at the highest level how it works, okay? All right, so we're not going to lose an entire region. We're still, even though we're going to kill off nodes of this cluster, we're going to maintain these 225,000 workloads. And while we're doing it, we're still going to get visibility. All right, so here we go. Let's bring it up, Mr. Anand.
All right.
Let's go to the leader before we get going, just to sort of show this. Okay, so if you don't mind bringing up, let's bring up the health dashboard. Now, because at the end of the day, the PCE is an application, it's not a black box, okay? We have some customers that actually monitor it from like an APM. That's totally fine if they want to do it that way. But we also have this little dashboard for an operator to look at. So let me just orient everybody to what they're seeing right here. So we have the US West, which is the leader, okay? And we have three members. There's the US East, which is in Virginia. We have EU East, that's the one in Frankfurt, and this EU West is our disaster recovery site for right now, okay? So let's keep that in the back of our heads as we start messing with stuff, okay? Let's go ahead and look at the EU East real quickly, Anand. So right now, we're looking at it from the master, and what you can see here is there's 4 core nodes, okay? And there's 2 data nodes, okay? So that's just from the leader, we get this view. Now, what I'd like to do is actually, let's go into that region so we can look at things a little bit more real time, okay? And so now we're looking at the EU East, which is running in Frankfurt. And let's take a look at it, if you don't mind, Dr. Anand. Thank you very much. Okay, so it's the exact same information that we saw on the leader, okay? Now what I want Anand to do is to simulate, like, what if there's a NIC problem? What if there's a switch failure? What if something actually goes wrong inside of that data center? So he's going to go, and for whatever reason, there's a failure on 3 of those nodes, and we should start to see those failures start to happen, okay? So are you doing it?
I'm doing it right now.
Okay, so he's going to start to fail those, and this is going to reflect those failures as they come up. Obviously, we're not a real-time application performance monitoring tool, but this is going to, because this is actually a live demo, we should start to see them do the failures. And what we will note is it's showing you all the CPU utilization across all these different core nodes here, and the disk usage and all this other stuff. And as they start to fail, we should start to see them drop down, and we'll even see some icons that show, hey, there's a problem here. All right, we've lost one of the nodes, and hopefully another one will pop out here in just a moment. And we also see some CPU utilization start to go up in the other nodes, which is something we would actually expect. And we've lost 2 nodes, and now we've lost 3 nodes. Okay, so we've lost 3 nodes within this specific region, all right? The next thing we want to do is that we can see that it's available because we're actually at the UI of this, and we could bring up workloads here. Why don't we bring up that point of sale application, the workloads of that point of sale application within that region. And remember, we're looking at it in the region with the failures. We're not looking at it from the leader, okay? We're actually in that region looking at the workloads that are currently attached to that specific PCE, and we're going to find that POS application, and we're going to see the workloads here. It's going to take a second. There we go. And we're only going to show the ones from Frankfurt. Yep, there we go. Okay, so right now there are 28 workloads living in Frankfurt, okay? And we've failed for whatever reason, NIC card failure, whatever, half of it has gone down, okay? But your business can't stop just because they have a problem with the PCE, because our customers demand that the PCE has to be as available as anything in their infrastructure. As DNS, as Active Directory, it is a core part of their infrastructure. So what Anand is now going to do is he's going to start scaling up workloads within that region with this hobbled policy compute engine within this region, because there's no reason why the business should stop just because you have to. And what we will see as we go up is you'll start seeing some new workloads begin to pop up in the Frankfurt region. And when they come up, they're going to start to inherit policy, okay? And are you using Chef again to pull?
Chef again,
Chef
yes.
is pulling up these. So what's happening now is he spins these up. The new workloads get paired to the policy compute engine using a pairing key. We actually have a really long pairing key. I think it's a 4K pairing key. But some of our customers use Kerberos tickets. Some of our customers use certificates. We don't care, okay? So it's really, once again, a way different customers operationalize this in different ways. And when those workloads come in, they get authenticated to the policy compute engine. The policy compute engine will say, oh, you're part of the point of sale application based on that ticket or based on that Kerberos, based on that certificate or based on that parent key. And then it will basically provision the policy down. Are we getting it now? Here, they're starting to pop up, it looks like. There we go. So he added the new name to the actual, to the workload name so we would be able to see which ones they are. And it's syncing to get its policies right now. Let's go ahead and drill down into one of those.
Let's go into this one.
Okay. So they've paired with the policy compute engine. Now we're synchronizing policy for those. And when they synchronize, they're going to inherit that policy that we wrote during the first demonstration. And remember, during that first demonstration, we ring-fenced all those workloads into one large sort of bubble here. And now it's going to go ahead, and we should be able to see the policy once it's actually downloaded here to this workload. And the policy propagation happens rather rapidly. So it's actually been able to get its policy now. And here's the calculated rules that got brought up to that workload that was paired to that hobbled policy compute engine within the EU East region, okay? So once again, we're just showing you how you can lose half of a cluster and the business continues to run again. question.
Yes. When did those 3 nodes failed, right?
Uh-huh.
And one just remained.
So no, there's going to be 2 core nodes and 1 database node that remain.
Remember, it's a 6-node cluster.
Is there any new leader election or?
Not at this point.
No, so he failed a member, okay? If the leader had been lost,
Yeah.
you promote any one of the PCs can arbitrarily become a new leader.
New leader,
Okay.
yeah?
Yeah.
Based on?
You choose,
You choose, yeah.
okay?
So one won't automatically take over, though.
No, one
You would
does
have
not
to
automatically
elect it.
take over at this
Okay.
time.
Got you.
All right, any other questions? Any
Yes.
member can be promoted to leader. And remember, it's important to remember this, okay, everybody? A member has all of the policies for all the regions, okay? A member knows, remember, a workload in US West is an unmanaged workload for EU East, right? So it understands the policy perspective and understands all the workloads. What happens when a member is promoted is now it simply becomes the central point for policy and visibility, okay? So it's not like a surgical operation to do it. Anything you want to add, PJ? Okay, all right. All right, so that was PCE regional problems. And even though we had a failure of some of the nodes within a cluster, it didn't mean that the business stopped. There's still business continuity. And one thing I'll stress, when we go into customers and we design these PCE architectures, one of the things, because it is software, if you deploy your data centers in pairs, we can separate it out across a region, right? Across different pairs. I've seen some customers, we really think about, like, as PJ said earlier, you could put a PCE running in Amazon. Amazon runs their data centers in pairs. You could put half of it in one data center and half it in another data center within the same region, and you have failover, cross-region failover, okay? So you could put it in separate racks. We have no religion around it, okay? And that's one of the big benefits of the product and just being purely software-based. All right?
You're going to address split brain here then in that scenario?
You want to talk about split brain?
Split brain in which
As in you've got not a failure of the node itself, but they can't talk to each other anymore.
so
and they
this is
both
the
think they're
master and the leader.
Yeah.
So that'll be the next
That's the next one.
demo.
That's the
Okay.
next one, yes.
Right, this is a single cluster, this is a failure within a single cluster,
Yes.
right? And so this group has quorum, has half of the nodes to survive. If we had one more failure, right, this cluster itself would decide to shut down because it doesn't have quorum to be able to operate any longer. So yeah, after the next demo.
After the next demo, okay? Any other questions? All right,
Okay, that one, I liked it.
okay.
How does
Okay?
Question.
can we do any change up to this point at the moment?
We can still change policy.
Okay.
We can still get global visibility.
Okay.
We can do all kinds of things.
When we do recover the failed nodes, how do we know they are synchronized with the
You will actually, so you would actually see this right here.
Okay.
If you scroll down, it'll show you the synchronization
Okay.
right there. So, in fact, one of the demonstrations we were going to do was to basically literally have 3 regions, kill off one region, bring up a new cluster running in another region in Amazon, but then there's a synchronization period and it might take a little bit too long, right?
Okay.
So instead we just decided to have a DR site, which is, by the way, what most of our customers do anyway. So because we have some customers that deploy PCEs just using Terraform, right? So they can literally hit a button, deploy a brand new PCE. And one of the benefits of this is we don't have because we don't charge for the PCE, it's a freebie, we just charge per VEN. That gives a lot of customers flexibility on deployment, right? So there's no licensing keys there. You can just put it inside of Amazon, you can put it inside of Azure, bring it up wherever you want, and you can use anything as HA or anything as DR at that point, okay?